Hi. Well, that's hi. So my name's Ben. I'm going to be talking a bit about some, not all, the ways that we use Docker here at Atlassian. A bit more specifically, I'm going to be talking about my team and how we let other people create containers and deploy them to production. So I'm going to be talking a bit about my team. That's the Micros team. And I'll be talking a bit about the products that we make and run, which is called Micros. I'm going to be talking about some of the aspects that makes Micros a little bit interesting. It might not initially seem so, but I think it is. We'll be covering some of the ways it's sort of set up, so you get a bit of an idea about what it actually is. And then I'll cover some of the lessons we've learned along the way, and we've learned lots of lessons. So, Micros, what is it? It is an internal microservice, platform as a service product. If you're kind of curious about where it got its name from, we kind of just deleted a lot of letters. We have an internal documentation site, believe it or not, it's on Confluence. And on that, we have a title that's What is Micros? And the What is Micros thing says a set of development and orchestration tools that interact with AWS resources to allow for quick deployment of services in the AWS infrastructure. I don't think that's actually grammatically correct, but it's also not a very succinct description of what it is. So I prefer to describe it like this. Micros is a bit like Heroku, but it's for internal services. We have lots and lots of services. Lots of them deal with customer data, financial data, very sensitive data. We really don't want to put that stuff up on Heroku. In addition to that, Micros is really deeply integrated into the wider ecosystem of Atlassian infrastructure. We have lots of stuff for authorization, communication, network connectivity, logging, metrics, all sorts of stuff. And when people deploy Micros, they get kind of free access to all of those bits of infrastructure that they'd normally have to actually build out themselves. And one of the really big ones for us as maintainers of the platform, but not for our customers or consumers, is that it's policy conformant. Traditionally, we've been a little sort of relaxed about policies. We only really had the one, which was that when things are deployed, they have to be tagged correctly so that the accounts department can actually tell who's spending money. But as we've become a public company, we're having to actually, become regulatory accredited or whatever. And some of those extra things that it puts on us are things like SOX compliance. Sarbanes-Oxley, something, I don't really care. Neither do our developers. They don't really want to have to deal with SOX, they just want to deploy services, so we're going through a lot of the actual hurdles of making things automatically become SOX compliant. Big benefit for them, pain in the ass for us. So we've been running it for a while, and we support a few different sort of artifact types. But the really interesting thing for us is that Docker has increasingly become by far the biggest consumer of our platform. I'll touch on this again in a little bit, but it's at least twice as popular as the next biggest group, which is JVM. And JVM itself is kind of a little bit of a cheat because it also isn't just Java, it's Java and Scala, everything that runs on the JVM. So Docker is a massive part of our infrastructure and we use it quite extensively. And the Micros platform is kind of part of the evolution of Atlassian Cloud. When you guys go to Atlassian Cloud, you sign up, you get Confluence or Jira or whatever it is you're signing up for. That's all running on another bit of infrastructure called Unicorn. And that infrastructure is a virtualization platform. It runs on a bunch of custom hardware in data centers, and it's kind of nasty to deal with, so we don't really do that. It is a really good solution, but it's very specifically tailored to the needs of Confluence and Jira. And as we're breaking them apart, we're making them more cloudy. A lot of that functionality in them is being broken out into microservices. And we had a really pressing need for a more general purpose solution to deploy services. And so that's where Micros came in. One of the interesting things is that Micros provides a lot of the functionality that you actually see on those cloud instances, but it's all hidden away behind microservices, so you wouldn't necessarily know. A lot of things like accounts management, files management, it's all built in and just running as microservices. And I'd be remiss if I didn't talk a little bit about Prometheus, because I'm going to mention it a few times. Micros isn't our first attempt at actually building a microservice platform as a service. It's our sort of second attempt. When we first started realizing that Unicorn wasn't going to be all of the solution that we needed something a bit more general purpose, we took a first attempt using Mesos. And we built up this big project around Mesos, and we spent about 7 or 8 months working on that. And we kind of liked it, but at the same time, the project was running well behind schedule, and it was blocking a few services that had initially bet on this new microservice platform, and they were going to deliver some pretty critical functionality, and they were getting blocked. So eventually the decision was made to sort of, whilst Prometheus was still happening, to create a little mini PaaS that was a much simplified version. It would only be AWS, it would reuse a lot of the infrastructure created for Prometheus, and it would just be a nice, easy, simplified layer for us to work with. History being what it is, it's kind of ended up subsuming the whole Prometheus thing, and Prometheus went off and burnt in a fire. So, when I get to the architecture, you guys might start to think this isn't actually all that interesting, which is why I put why is it interesting first. One interesting fact is it's been running in production since 2014, running production workloads, and that's about May we made the first release of it. And from that very first release, it was running production systems that were backing functionality in Atlassian Cloud. We ended up waiting about 4 months before we had Docker support, so about September 2014, and we had massive adoption. Straight off the bat, some of our heaviest consumers moved to Docker containers, and they've never moved back. I find this kind of an interesting one because there aren't actually too many use cases of people who've been using Docker containers in production in a really big capacity for many years. So, I don't know, I think it's a little interesting tidbit. Another interesting little tidbit is that it's running lots of services. A lot of the solutions we've looked at over the years sort of can run a certain amount of workloads, but as you scale them up, they become harder and harder to manage. So I ran some stats last week, and we had 696 services running across all of our environments. We've got 3 different development environments. We have 2 staging environments and 2 production environments. There's geographic splits there so that we can target different customer bases and things. Of that 696, a lot of things, the customer services that you'd interact with, things like perhaps Blob Store if you've ever done file uploads in, say, Confluence. But it also includes a lot of things like the wallboards that we have on pretty much every floor, showing all the statistics from our services and giving us insight. And then it also just has stupid things like little hip chat bots that tell people who won in the latest game, Ping Pong. It's very popular for Ship It, which, if you haven't heard, is our once a quarter hackathon, 24-hour hackathon thing. It's also very popular for 20% time projects because people can spin it up and deploy it, and they can kind of ignore the cost, whereas that may not be an option with something like Heroku. Of those 696 things we have 206 fully productionized services. For us, there's a few more steps for going to production than just running it to another environment. To get something fully production ready, it means that we've got on-call rotations set up, it means we've got disaster recovery enabled, it means it's deployed in a way that's fully HA. There's a lot of extra steps involved in getting to production, and we see a fairly good rate of people getting through the more preliminary environments and getting into production, which is nice. Talking specifically about the production services, 51% are Docker containers. That's actually a little bit higher than our platform average, and that's because we find a lot of people will start out working with one of their more generic types, say they're deploying a Node application, they'll publish that to the internal NPM registry, they'll deploy it straight to Microsoft, they'll keep working with it, and then they'll go, you know what, I kind of want a new node runtime. That's when a lot of people start to switch to a Docker container. They want more control over their application runtimes, the libraries on the system. They need to actually have really good, tight control over the system as a whole. They package it up with Docker, send it to production. One of the really nice things about Micros, and I'm saying this kind of as someone who's on call all the time, is that it's a really robust system. One of the things we got when we moved away from using Mesos as a scheduler was that we were actually able to make AWS a sort of pseudo scheduler for us. And that's really reduced the burden of operation on us as a team. One of the really nice aspects of this is that we can actually completely lose Microsoft Server, and there'll be no interruption to any of the running services. The only thing that goes wrong if we completely lose our servers is that new deploys are blocked. Apart from that, everything keeps running smoothly, and we have as much time as needed to get the server back up as needed. Unless it's like a region failing event, in which case we've probably got bigger problems. And this is the part that I really like the best. It's the simplest thing that can possibly work. You can certainly have a look at some of the other solutions. Kubernetes is particularly cool, Mesos is really cool, but they add a lot of complexity to your solution. One of the really nice parts is that we have a very simple solution, and we're actively working every day on making it an even simpler solution, because we just, any extra complexity has very tangible cost to us, and we really need to eliminate that. So, what does Micros actually look like? So the last time we sat down and made an architecture diagram, it kind of looked something a little like that, which is kind of cool and all, but we can probably ignore some of the really Atlassian specific parts, and we can probably ignore some of the parts we've deprecated and decided to move to other components in the greater Atlassian ecosystem. And we can probably ignore some of the third-party services like Kingdom and Datadog because they aren't really part of our core infrastructure. And we can probably ignore some of the non-Docker stuff because it's a Docker meetup. And at this point, this diagram's become useless, and we can probably just redraw it. So welcome to my simpler, smaller diagram. So everything really revolves around Micros Server for us. It basically mediates all customer interaction, and also it mediates all other services interaction with AWS. Users interact with the server via a command line tool, and we also have that command line tool deployed to Bamboo, so all our continuous integration jobs and things can also deploy to Micros environments. Users will interact with that, and they'll talk to Micros Server, say they might be trying to trigger a new deploy of their service. Micros Server will actually deploy a CloudFormation stack straight to AWS. AWS will be returning back a bunch of information like events and stuff. We stream that information all the way back down to the user's command line tool, and they can watch the status or just kill it like most people do. In addition to that, we've got a resource provisioning service. We tell most people to try and aim for like a 12-factor, stateless, simple application style. And one part of that is that you need backing services like databases. That's where RPS comes in. If someone specifies in their application manifest that they require a database, when they do that first deploy, Micros Server will actually talk to the resource provisioning service, create like an IDS instance or something, and those details are passed back into Micros Server, which will then create the stack and inject all of the connections and IAM roles and things into the actual application to be delivered. Additionally, we have a cron service, because we just have to. Essentially, we have a bunch of cleanup tasks that need to be done. The reason we end up having a lot of cleanup tasks is that when someone tries to trigger a new deploy, we don't delete their old stuff immediately. We actually leave it hanging around for an hour because it really covers a lot of those, oh shit, I just broke everything and need to roll back immediately type situations. If that happens, we just do a DNS switch over, point back at their old stack, and delete their new stack in an hour. So cron handles a lot of that deletion type work for us. And then when an instance actually comes up and it needs to pull down the application binary, it'll talk to our internal Docker registry. I'll talk a little bit more about Docker registries later. They're a lot of fun. So, this is a really simple diagram. This is essentially what services that get deployed by Micros look like. When they first get created, we create a Route 53 DNS record per service, per environment. So you can deploy to dev, staging, and production, and you'll have a slightly different URL for each one. Behind that DNS record, we create a whole new set of infrastructure, load balancer, autoscaling group instances per instance of your application. So when you create a new stack, we'll create, first of all, the ELB. We'll point the DNS record at your new ELB when the service is passing all its health checks. When that's happened, we have an autoscaling group that brings up instances. Those instances are spread over multiple availability zones, and we can also give multi-region level redundancy if needed by just deploying the stack to the 2 different production environments, US East, US West, potentially Europe or something if needed. If we do have a backing service like a database, when it's first created, the stack will have environment variables with all the connection details injected into the runtime or to the environment of the runtime, and we'll also attach IAM roles directly to the instances so that the instances can actually securely communicate and not communicate with someone else's instance. So, what are some of the lessons we've learned actually running a big, not entirely complicated, but yeah, interesting system? The first one is don't chase the latest version of Docker. It's really tempting. Lots of Docker versions come with lots of really cool new fixes. I personally love 1.9.0. It included a whole bunch of bug fixes around pulling things concurrently. We find that whenever we update, we break someone. It's not really great, but there's a really careful trade-off that needs to be made between actually upgrading it and retaining like the fixes and things. One of the things that we find is probably really beneficial is that we actually really engage our customer base, users, customer base, to actually go through that upgrade process with us. We'll actually create like an optional flag or something to opt in. We'll get our heaviest Docker users to actually opt into that new version, deploy a version, check that everything's running as expected, and then if we pass everyone's tests, including our own, then we'll actually roll out to our greater user base. It really pays to be very careful with upgrading. In our case, we can't make an AMI for all use cases. We initially tried by making an AMI that has a whole bunch of language runtimes on it. People would deploy, all we'd have to do is support the ability to pull down a specific binary, run it on that runtime. That worked fine for a little while, and then, new major versions of runtimes came out, and we couldn't upgrade to them because some people were locked to some specific feature of an old runtime. So we kind of then started to have this growing disparity where we couldn't upgrade without breaking people, but then new people couldn't deploy things without having the newer version, and that's where Docker really saved us. We essentially let people develop things with whatever runtime they want, and then as soon as they start needing specific versions of things, we just say, go to Docker, we'll be fine. We run a little training course for anyone who's not really comfortable on how to actually switch to the Docker sort of setup for them, and we've been finding that it's not a terribly difficult transition for most people. Docker registries. Yeah. So we ran a Docker registry, the original one, not the V1, the 0.91, as the developers are very happy to tell you. We ran that for about 2 years, and it worked fine initially. And then, more people started to adopt Docker. That increased the load on our registry, and that sort of kept repeating over a 6-month period. And then we started finding that the registry would start failing. People would try to do a deploy. The registry would just send half of the image layers down, and then it would start returning 500 error codes. We never actually really worked out what happened here. We just scaled up so high that the probability of it actually occurring on any one request was greatly reduced, but none of those boxes really had much load. We never really worked out what was up. In the end, we switched to the registry V2, which is called Docker distribution, just to keep things nice and simple. Since we've migrated to V2, we've had a much more stable repository. It's worked really well for us, but actually switching to V2 was quite a process for us. Anyone else who's gone through that transition might have noticed that Docker provides a tool that will basically sync down all the images from one repo and sync it up to the next repo. And that initially seems like a good idea until you've got like 2 terabytes of images. So it didn't really work for us because the Docker daemon locks up after you pull down about 100 gig worth of images. In the end, we had to write a little script that was quite similar to that, but it did it more incrementally, pulled down a little bit, send it up the new one, wiped its local cache, kept repeating that. And then once we had kind of a replica on the V2, we ran both of the registries in parallel, and then we actually modified that original script to sort of diff the V1 whenever anyone pushed to that. We'd also then sync that across to V2 so that we kept them sort of in sync. Eventually we deprecated the V1 one, and life was a lot better for us. Log aggregation. Also a really tricky one when you have 600 services. We initially created basically a fluentd log aggregator shipper on all of our instance nodes, and we had an Elasticsearch cluster per environment, and we sent logs to Elasticsearch. And that worked fine for a few months, and then we realized running Elasticsearch clusters is actually not a trivial job, and they all fell over. We threw quite a bit of money at them by just doubling the amount of nodes, and that sort of deferred the problem for like another 2 months, and then it all happened again, and then a few iterations of that, we went, all right, this is becoming a real problem for us. We actually split a few members off of our team to create a logging team, and they've gone on to create a new product, the internal product called Logging as a Service, and that's essentially a giant Elasticsearch cluster ingesting off a Kinesis stream. So what we do now is we just use fluentd in a container on each host. Logs get sent to the fluentd container, we send that off to a Kinesis stream, and then Laz does magic. I'm just looking at some of the members down the back who are not meeting my eyes right now. Rules. Rules are a really difficult problem when you're the runner of paths. Every developer's kind of a special snowflake, and the corollary of that is every developer wants root access to everything. And every single one of them will have a very good reason for that. A large part of our jobs is working out why they want access to parts of the system, working out what actually makes sense there, if it's a general use case, what should be done as just a once-off task by an admin of the system, what should be made available to members of our system. One example of that is we recently implemented a feature that will go and undeploy applications that are sitting in our development environments after 7 days. And the main reason we did this was because A, people would just deploy something and then utterly forget about it. But more importantly, B, we found people started to run production services in development, and that was kind of great until they realized it had no HA, no disaster recovery. The databases are a bit more ephemeral in dev, and people started having bad things happen. But where another example of that also is, we also found that people had a real need to be able to spin up more Docker containers when they ran a service. We have a file conversion service, and we really found that they needed to basically have access to the Docker socket. So we allowed them to people to mount the Docker socket into one of their running containers, and they can actually spin up much more containers as needed. In that specific case, they use that to actually manage file conversion tasks, where they'll receive an image, they'll create a bunch of containers, one container to convert it into each different file format. That's sort of the thing where we look at that, we evaluate the use cases. We may actually stop allowing them to do that in the future by allowing them to, say, have an ECS cluster as a backing resource to their application. Upstream tooling, it's better than your tooling. When we first started Micros, we inherited a lot of things from Prometheus, which was great. It let us get set up, it let us not have to worry about VPCs and network ACLs and getting connected to the rest of the greater Atlassian network. Where we actually struggled with that was that a lot of the tooling that came with it was custom made with no documentation. And only like 2 developers in the entire company knew how to use it. So we eventually spent quite a lot of time, migrated all the functionality out of those custom tools into Ansible. And since then, we've been able to actually hire developers who know how to use the tools. We've been able to get other people, other teams to come in and submit PRs. Basically, using an open source tool that's kind of in industry standards being a big benefit. Who knew? AWS limits. Anyone hit AWS limits in the past? Yeah, a few people. You don't count. So AWS limits are fun. They're entirely sensible. We fully approve of AWS limits. They're a great idea. Where we have a problem with them is that we don't really have insight into the limits. Limits on their own are fine when you can actually say, hey, I'm 20% of my way through this limit. Limits are a bit more of a problem when we start getting hip chat messages saying, hey, I can't deploy anymore because of this limit issue coming up in my console. Unfortunately, our users are probably our biggest limit finding thing in AWS. It's usually really quick and easy to resolve. We just submit a ticket and we normally have the limit raised in like a matter of minutes. But A, it's not a very user-friendly feature. And B, there's some more insidious issues that aren't necessarily immediately apparent. One of the really big issues we've had in the past is that you can have, say we saturate our E or B API limits. One of the things that isn't really documented is that if you saturate your E or B API limit, auto-scaling groups aren't going to automatically scale anymore. They fail to detect that instances behind have gone unhealthy or under load, and they'll just sort of sit there idly going, eh. So that actually took us a while to work that one out, but if we've been working with AWS to get better insight into those limits, but until we do have proper insight, it's a real pain point for us. Monitoring. Monitoring's become a huge deal for us. When someone sort of comes up to you and says, hey, we're not getting the right database throughput that we expect, until we had proper monitoring on that, we were just kind of like, yeah, make a new database? I don't know. We've been working on adding more and more monitoring to our system so that we can actually see the performance as a whole, but then also really drill down and get really detailed metrics on individual parts of our system. And this has probably been the #1 thing that's helped us really sort of become much more operationally mature, really get down the amount of incidents at 3 a.m., all those sort of things that you really just don't want to deal with. We use CloudWatch extensively. We have all the standard metrics. We also have some of our own metrics that we ship into it. And in production, we also ship those metrics into Datadog, and we have the Datadog agent on all our boxes. So that gives us really a good level of system metrics. We also have logging as a service, as I mentioned earlier. That lets us ship all the logs. We can see any anomalous behavior in logs. And we also have StatsD running on in our environment, which lets us send application level metrics to a cluster in dev and also to Datadog in production. In addition, we have tons of warboards. If you walk around our offices, you'll see just TVs everywhere. That's all warboards. And we also have a ton of alarms which go through to PagerDuty and make us unhappy. Complexity. Complexity has a real cost. It's a maintenance burden, it's an operational burden, it's kind of just a pain. We've been definitely working to reduce a lot of the complexity in the platform. We're deprecating parts of it left, right, and center. We inherited a lot of them just from Prometheus, and we kept running them just because. But what we're finding is that they tend to flake out. You might run an LDAP replica for a year, and then it suddenly dies, and everything that was pointing at it suddenly goes haywire. We're deprecating as much of that sort of stuff as possible, and we send it upstream to teams that actually have a job of running LDAP servers. We're finding that for tons of our infrastructure, logging, we created a separate team for, LDAP, proxies, tons of our infrastructure, we're trying to get rid of it. The flip side of that is that we're continuously evaluating other solutions, and we really like the way that Mesos has developed. We're also really keen on things like Kubernetes, some of those other projects, but they definitely are a much bigger management burden on the team. We've never had AWS ring us up and say, sorry guys, we lost consensus on your system due to a network partition and we just need you to redeploy all your services. Whereas we have seen lots of weird little bits of behavior when we put some of these services under really heavy load testing. etcd can do weird things, Zookeeper can do weird things. Network partitions are not your friend. So we're quite interested in a lot of those more clustered type solutions, but we're aware there's a really heavy burden to them, and we're kind of really cautious about that. I like this one. Occasionally, you're going to have to just say to all your customers, we changed a thing, and you all need to change your things now. A good example for us is that we used to run a bunch of proxy servers because we were told we were meant to, and you know, that kind of works, but most libraries don't really support proxies very well or at all. So after a long and arduous battle, we've moved to a NAT. We have a team that does network magic. Sam up the back there knows more about it. And yeah, we've gone through that whole process, but unfortunately we can't really just turn off the proxies because there's going to be some old systems out there running it. There's tons of situations where we've had to change something, and it involves harassing all the customers. And you know, it's something that you need to be aware of, but it's not necessarily a big deal as long as you can engage with your customers and discuss that in a venue that is, you know, sort of good. We're actually adding ways now that we can automate the redeploying of services that are actually running, but we still need to give a certain amount of leeway on that. It's a dangerous process to automatically redeploy someone else's service, so we're still sort of looking at ways to manage a lot of that risk. And quite possibly, the most important thing that we do as the maintainers of a PaaS is that we engage with our customers regularly and extensively and thoroughly. We have a quarterly feedback survey that goes out to all the developers that use our system, and by far one of the biggest adoption factors for them is that we have a small but very strong and engaged developer community. Anyone can have problems and they'll ping us in our HIP chat room and they'll have an answer, usually in minutes. Usually from one of us, but the good thing about building up a bit of a community is that we also have a big group of users that also know the answers to everything. So that's been a really big thing for us. We also have help desks, and we also run a monthly user group where we just have all the developers who use us come in, we order a bunch of pizza in, and we just run through all the latest changes. We find out about anyone who's onboarded with us recently. We tell about any important announcements. It's a good way for us to catch up with our users and for our users to catch up with what we're doing. It helps us really sort of keep in sync with each other, and it's really probably the most important thing that we actually do. One of the nice things too is that we actually have people come to us quite regularly, and not even necessarily talking about micros, that actually just come to us and want to know, you know, I'm thinking about moving down this direction with my application. What are some of the steps I can take to get from this legacy thing to this sort of new microservice architecture? And we walk through a lot of that process with them. So it's by far, that's the most important thing that we do. Thanks. Any questions? Yeah.
Over there, back there. Have you looked at the Amazon Elastic Container Service versus your own service, and what did you think?
So the question is, what do we think of ECS versus our service? We quite like ECS. We actually have some of our internal components using ECS. For example, we have a replication service to replicate data between two regions, and we use ECS for that. It's got a few limitations now, but I think those limitations are going to be addressed relatively quickly. AWS is great at fixing those sorts of problems in 3 to 6 months. Yeah, as it stands today, we can't migrate our users to it, at least not in a meaningful way, because some of those limitations just prevent us from actually doing that. We can't deploy things quite as fast as we want to. We've found that when we deploy many hundreds of things to it, it sort of starts to break down a little bit. And what was the third one? There's another limitation that we found that was sort of a bit of a blocker for us. I think it'll be addressed, but as it stands today, it's not really an option. Something like Kubernetes is probably closer to being ready for us to adopt. And we've got a few little demonstrations of us actually being able to deploy a service from Micros to Kubernetes in a dev environment. It's kind of a fun little proof of concept, but we've still got a few questions that we need to work out about getting HA with Kubernetes working. Any other questions?
A couple of questions that
Yeah.
As you were talking about the AWS stuff, basically you have around things on the AWS side. So is this going to be microservices cloud agnostic in future that hybrid, or just only meaning?
Good question. So the question was, are we aiming to become cloud agnostic in the future? That was actually one of the primary goals of Prometheus, and that's burnt. Micros as it stands today is not aiming to become cloud agnostic. We're heavily tied into things like CloudFormation, RDS, a whole bunch of AWS technologies, and we have no plan to transition off them. And as a company, we've sort of decided on AWS is what we're going to use. Having said that, as we look into some of the things like Kubernetes, Mesos, we're looking into a couple of other sort of commercial PaaS type things that we could integrate. We are keeping in mind that if we adopt one of those solutions, we then do have an opportunity to actually make that, say, like an on-prem solution for a lot of our things. And we have other teams that definitely want to use Micros, but on-premise. So we're looking at ways to address that. Especially, we have a few customers that really want to be able to package up a lot of their Docker containers and run it in the same way, both in the cloud and on-premise. So we're looking at it. It's not our primary concern, maybe not even our secondary concern, but it is something that we'd like to perhaps address in the future.
Another question? Yeah.
Yeah, my question is, you're talking about some tools to migrate the V1 to V2. If that tool is already open source or still in I'm very interested because we are currently working on this.
So the question was the tool that we created to migrate from the V1 registry to the V2 registry, if it's open source. The answer is no. We probably could make it open source. I don't see any reason why we wouldn't, other than laziness. I don't know if James is standing around at the back. He said he would be. He's not. We probably could make it open source. There's nothing really secret about it. It's just a little Python script that I think it looks at the search endpoint or something on the V1 registry, diffs it, works out if there's anything changed since the last time it's evaluated and sends it across. I don't know. Come talk to me afterwards. I'll open a ticket or something.
Chris?
Considering those comments before, have you considered maybe like a cloud management platform and then Kubernetes or Ranch or a Swarm on top of that?
On top of AWS directly?
On top of the cloud management platform.
Okay. So the question was, would we consider something like Rancher or Kubernetes or something on sort of cloud management platform? The answer is kind of no. As a company, I guess we've made the decision to go all in on AWS, and we don't, partly for a few reasons. One of them is just compliance. We have to go through a very long and arduous process these days, now that we're a public company, to actually start using new services, and I, for one, I'm willing to get involved with that. But I mean, we've had AWS approved for us. We haven't had any other vendors approved for us. Actually, I think we might have Rackspace. Redact that. No. Yeah, I mean, we're all in on AWS. As we do go and play around with things like Kube, though, we are keeping some of that stuff in mind. It's an option for us, but realistically, we're probably not going to migrate off of AWS to anyone else.
Any further questions?
Yeah.
I've had experience with deploying Docker containers and particularly with delays from pulling from the registry sometimes. So we looked at things like using a cache. Or is that something you guys looked at, or have you addressed that in other ways?
So the question was, how are we addressing problems with delays pulling from the Docker registry, and if we're using cache? The answer is no. We migrated to the V2 registry. Once we're on the V2 registry, we found that it resolved many of the problems we had with the V1 registry, and from there it was just a matter of scaling a few more boxes out. We haven't had any problems with pulling or latency or anything like that since we've made that migration. It may also depend on what you're using as your backend. So we use S3 as our data backend. If you're using a different backend, you might have different performance characteristics.
Have you looked at Amazon's new registry service, or are you using the internal?
Yep, so the question was, have we looked at the internal one? Yes, we have looked at the internal one. It's kind of cool. It's kind of a little difficult for us to switch to it at the moment because the current registry that we have is backed against our internal staff directory. So it uses credentials, like user credentials, and we have bot accounts. We've got a full trust chain set up all around the company. The one that Amazon provides is based on IAM, which is kind of cool. That's actually really interesting from the actual runtime environment. It kind of makes it a little more difficult for us in terms of actually people pushing and getting images into it and things. It's definitely something that we were going to consider if the V2 registry didn't work out for us, but the V2 registry has worked out for us so far, and it's hasn't made any change in kind of our user-facing contract and how you actually authenticate and authorize things. So we haven't really needed to switch away from it.
Last question, yeah. Oh, you did? You just answered. Okay, cool.
Cool.
All right, thanks very much, Ben.